Okay, so we do have a corollary to the side splitter theorem. This states that if 3 or more lines divide 2 transversals, or 3 or more lines are parallel going through 2 transversals, then those lines split those transversals proportionally. So what that means is that these 3 lines are parallel. And it splits on these sides here proportional, meaning A over C is equal to B over D. That's one way of writing it. Let's write all the possible ways that we can write this. You can also flip these reciprocals around, or the fractions around to do the reciprocals. C over A is equal to D over B. You could have also used A over B is equal to C over D. Or flipping those fractions around, you can do B over A is equal to D over C. You could have also used similar triangle rules, which states I can do A over A plus C is equal to B over B plus D. Or I could flip those around to have A plus C over A is equal to B plus D over B. Or we could have went across. A over B is equal to A plus C over B plus D. Or we could also flip those fractions around. B over A is equal to B plus D over A plus C. There's so many different ways that you can write your proportions. But the corollary of the triangle side splitter theorem would be these 4 possibilities right here. The other ones that I wrote are just using similar triangle rules. All right, so number 23 says, using the length of the segments in figure 2, we're going to write at least 3 proportions that are true. So we can use the corollary of the side splitter theorem. So I can write 9 over 15 is equal to 6 over 10. That would work. That's one way. Another way that you could write it is flipping the fraction around. 15 over 9 is equal to 10 over 6. Another way we can write it is we can go across. 9 over 6 is equal to 15 over 10. I want you to pause the video and write down the remaining. I know it said only at least 3, but I want you to write down the remaining of the true proportions that we can actually write down here. I believe there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 different ways that you can write your proportions. And these are all the ways. Up here, I didn't write down all the ways because I could have also done C over A plus C is equal to D over D plus B, and so forth. All right, for this one here, any lines that appear to be parallel are parallel, so that means that AD, BE, and CF are all parallel, and we're given that AC is 60. We have DE being 15 and EF being 39, and we want to find BC. For this one, we actually label BCX. We're not going to use the side splitter theorem. We're going to use similar triangle rules, because if I do X over this whole side, 60, I would need to do 39 over this whole side, which is a 15 plus a 39, or a 54. I then cross multiply to get a 54x is equal to a 2,340. Dividing both sides by 54, I get x is 43.3 repeating, which is the same thing as 43 1/3. All right, moving on to the next problem. It says I want to find x. We are going to use the side splitter theorem, or the triangle proportionality theorem is the same thing because we have the two parallel sides. So there's many different ways that you can set this up. I'm going to set it up as 2x minus 2 over 1 is equal to negative 7x plus 2 over 7x minus 2. When I cross multiply, I need a FOIL here. So a 2x times a 7x is a 14x squared. A 2x times a minus 2 is a minus 4x. A negative 2 times a 7x is a minus 14x. And a negative 2 times a negative 2 is a plus 4. Equals a 1 times a negative 7x plus 2 is just a negative 7x plus 2. So this is a quadratic. I'm going to want to set this equal to 0. So I'm going to want to get this negative 7x over here by adding it over and subtracting this 2 over. So I have a 14x squared minus a 4x minus a 14x is a negative 18x, and then I remember I'm adding this negative 7x over. So a negative 18x plus a 7 is a negative 11x squared, or x. And then subtracting that 2 over, I have a plus 2. Okay, so now I need to solve this quadratic equation by using the x method. And the top of my x is my a times my c. 14 times a 2 is a 28. And the bottom is my b value. I need two numbers when multiplied together equal 28, but when added together equal negative 11. That's going to be a negative 4x and a negative 7x. So rewriting this, I have it as follows. Using grouping, and then factoring out the GCF. My GCF out of my first two are a 2x. I'm left with a 7x minus a 2. I would need to factor out a minus 1 out of my next two to be left with a 7x minus 2. So one of my binomials is a 2x minus 1. My other is a 7x minus 2. Setting them both equal to 0 and solving for x, I would get x is 1/2 or x is 2/7. But we need to check to make sure that these are realistic within our work. Well, if I put a 1/2 in here, a negative 7 times a 1/2 gives me a negative 3.5. Plus a 2 would give me a negative side length. So 1/2 does not work. If I put a 2/7 in here, a negative 7 times a 2/7 would bring me to a negative 2. And a negative 2 plus a 2 gives me a side length of 0, and side lengths can't be 0. So 2/7 doesn't work. So the two x values that we found don't work. So what that means is that there's no solution to this problem. All right, looking at number 26, I'm given that B, C, and E, F are parallel. So I can use the side splitter theorem. So I have my x minus 10 over 4. and that would equal 4 over x. Cross multiplying here. I have an x squared minus a 10x is equal to a 16. This is a quadratic, so we need to set it equal to 0. So I'm going to subtract that 16 over. And now let's use the box method. Split up my x. Two numbers when multiplied together equal -16, but when added together equal -10. There's actually no such two numbers that do this, so that doesn't mean that this is no solution though. It just means that we cannot use this method to solve. There is a method that we learned for solving quadratic equations that works for every single quadratic equation that you have, and that's the quadratic formula. So that's what we're going to use. X is equal to the opposite of b plus or minus the square root of e squared and -10 squared is 100 minus 4 times my a times my c all over 2 times my a. Simplifying what's underneath my square root first, I get a 10 plus or minus the square root of, and then just typing a 100 minus a 4 times a 1 times a -16, I wind up with a 164. And then I'm also going to simplify my denominator. A 2 times a 1 is a 2. So now I'm going to type this all into my calculator, and when I do so, I need to put parentheses in the correct place. So I start off typing parentheses, and then I type 10 plus the square root. Your calculator inputs this yellow parentheses in. We're going to type in 164, and then we need to close the yellow parentheses and close the very first parentheses that we put in. Divided by 2. We wind up with x is approximately equal, we're going to need to round to the nearest hundredth, 11.40. Now I'm going to do that again, but with my minus sign. So parentheses, 10 minus the square root. Your calculator put in this yellow parentheses. 164, I need to close the yellow parentheses and close my own parentheses, and then hit divided by 2, and I get a -1.40. Now x is a side length here, so I know that it cannot be that -1.40. But if I put 11.40 in for all my x's, they do actually work out to give you positive side lengths. So this is your answer. All right, that brings us to the end of this video. Have a good day.